Hi, this is Mr. Ward. I'm going to talk about Chapter 8, Section 2, which is similar figures. There's a couple of very key definitions and theorem that you will need to work with here. So we're talking about similar polygons. And the big idea about similar polygons are two things. One is their corresponding angles are all the same. And the other is that the ratios of measures of corresponding sides are equal. So 8 is to these two triangles, of course, have all the same angles. So angle, angle, angle will prove similarity but not congruency. And 8 is to 12 as 4 is to 6, because both of those boil down to 2/3. And 10 is to 12 as 5 is to 6. And 8 is to 10 as 4 is to 5. Both of those boil down to 4/5. 10 is to 12 boils down to 5/6 when you reduce it. Now, relatedly, the perimeters of any two similar figures, the ratio, I should say, of the perimeters of two similar figures will equal the ratio of any pair of corresponding sides. So if we look at these triangles, okay, we can add up the sides. So 4 plus 6 plus 5 is 15. And here, 8 plus 12 plus 10 is 30. Okay, so 15 is to 30. Okay, and 6 is to 12. 5 is to 10. So those are all halvesies. So this triangle, all the sides are half the side lengths of this, and its perimeter is half the perimeter of this as well. Well, there's a proof of Theorem 53 in the sample problems that you'll want to take a look at and see if you can make sense of it. But I'm only asking you to deal with a few questions. The first few are really just think questions. What do they appear to be? So which pairs of figures appear to be similar? And what you're looking for is, do they scale up and down, have the same angular relationship? There's only one set here that definitely appears not to be similar. They have to have the same corresponding angles, or actually the same corresponding curvature will do the same thing. All circles happen to be similar to each other because they all have the exact same curvature. Okay, and then on to which ones could be proved to be similar? Well, these two can be proved. This is a little less obvious, but since these are equilateral triangles, you know that they'll have 60, 60, 60, for example. You know that this is a 40-degree angle and this is a 40-degree angle, but this is 4 to 5 and that's 8 to 10. Those are the same ratio. So the corresponding sides have the same ratios. 4 is to 8 as 5 is to 10. You can do the proportion that way as well. Here, we don't know what this angle is. We know that's a right angle, but we can look at the sides. 9 is to 6 as 12 is to 8. That's a 3/2 relationship. 15 is to 10. That's a 3/2 relationship. This one, we have one corresponding angle, and we have 8 is to 4. That would be a 2-to-1 ratio, but we don't have any other sides to confirm. So this side here, this angle down here might be a different angle than this one. So we don't have enough information there. For number 3, we've been given NPR is similar. That's what that symbol means. Similar. So NPR is similar to STV. And we know angle P is 90 degrees and angle R is 60 degrees. Well, that means that all the angles that are on here are going to be the same. So if P is 90 and R is 60, then this one N is 30. So S is 30, V is 60, and T has to be 90 as well. So here we need to find EF. We know these triangles are similar. A, B, C, D, E, F. The order of the letters does matter because it tells us which angles correspond to each other. And A, B, and D, E are corresponding. B, C, and E, F are corresponding. So we know that D, E is half of A, B. So EF should be half of BC, and I'll let you work out what that is. Move my face over here. Okay. Number 5. So we have been given circle O and circle P, and we have triangles AOB and RPS are similar. And we know that OA is 2, and AB is 3, and PR is 6. So we want to find PS and RS. Well, PS and RS. So if we know that OA is 2 and AB is 3, and we know PR is 6, PR corresponds to OA. And so that's 3 times what OA is. And that means that RS is going to be 3 times what AB is, because those are corresponding sides. And since it's a circle, OA and OB are radii, and PR and PS are radii. So the radii for P are both going to be the same. The radii for O are both going to be the same. Let's see. We've got 9 or 10 are the other ones you need to deal with. So 9, we just need to figure out what WY is. And we've been given that these two triangles are similar. So WY corresponds to SV. We have this ratio of WX and ST would be 8 to 10 or 4 to 5. So you can use that to figure out what WX is using a ratio, using a proportion. Okay, because WX is to 7 as 8 is to 10. In this quadrilateral, we want to find the ratio of the lengths of the corresponding sides here and here. We know the quadrilaterals are similar, and we've been given it as A, B, C, D, and H, G, F, E. So we know that H and A correspond, G and B correspond, F and C, and E and D. And so the sides that are in between them also correspond. So we've only got one side on HGFE, but we can use that to build all the other sides. So 6 is to 9, so that's 2/3. So all of these sides should be 2/3 of their corresponding sides. So we want to find EF. EF will be 2/3 of DC, because that's the ratio. Perimeter of EFGH is going to be 2/3 of the perimeter of DCBA, or ABCD, depending on how you want to name it. And so we can, and the ratio of the perimeters will be the same as the ratio of the sides. Hopefully that was helpful.